Hello, my name is Matthew Demo, student number 100610337, and I'm with Jarvis Ortega, student number 100625970. And I'm just going to show you our program for the challenge. So we have, you can see our yellow ball in the middle here, which is our controllable character, and these other supposed fishes moving randomly. So this is challenge number 2 with the fish. And you can see here, if I change the mode, we have our blur going on. If I change the mode again, we have our specular light. If I change between the default and the lighting, you can see the difference between the specular light with and without it. And then here we have our code for the lookup tables, or the difference after the lookup tables. It's just a slightly more purple hue. I'm just going to walk you through a bit. So the first thing with the objects moving randomly is just here. When we create the objects, we're just going to set them with a random x and y velocity, and when they update, and here we're just going to move them based on their velocity, and if they reach the edge of the screen, I'm just going to reverse their x or y velocity based on the edge of the screen. So that's as simple as that is there. For the controllable character, sorry, it's just here. It's a keyboard callback function. If we press W, A, S, or D, it's just gonna set the position of the character based on the key you're pressing. Okay, so the next part I'm going to talk about is the frame buffers and the blur function. So for that part, essentially what a frame buffer is, I'm just going to talk about both of them at once. A frame buffer is you are going to be drawing to, instead of just the screen itself, you're going to be drawing to this frame buffer, and then you can use the RGB values of the frame buffer to sample from and draw to a quad that you can adjust the RGB value from and do some post-processing effects like the blur. So up here we are binding this scene frame buffer, which is just going to be the default scene with just the whatever default values, RGB values we're going to draw to it. And then we're going to unbind that, and we are going to go in here, and when we change to this blur mode, we are going to do a box blur. So in here we're going to, first thing I do is I have a frame buffer that I reduce the resolution of by 8 up at the top here. Over here I reduced that by 8. So what that's going to do is that's just going to reduce the amount of pixels. So when I do the blur, it's going to make it seem blurrier. And then I'm going to send the texel size to the shader, which is going to be 1/8 of the screen resolution, and I'm going to bind the default scene that we drew before as a texture for the shader. So then if I go to the shader, this box blur shader, you're going to see that this sample 2D U-Bright is going to be the RGB values that I'm binding to the shader. So this, in the shader, I have this array with five elements in it, or 9 elements in it, sorry, and these are in the array the texel coordinates that are surrounding the pixel that is being blurred. So if I look at 4, that is just the UV coordinate of the pixel I'm working on plus 0, 0. So that's just the pixel I'm working on. If I go to the third demo, that's the pixel to the left of the center element, and I'm subtracting the the x element of texel size from the UV, so that's moving to the left by the texel size. If I want to move one pixel to the right, I add the texel size to the UV. And then what you do is you pretty much just have this this summation of each of the surrounding texels divided by 9, and then that's just going to blur the output value of the texel. So that's not too difficult. And then I believe that is it for me, and I believe Jarvis will take over with the rest of it.
Okay, hold on. Okay, so to implement the fuse specular ambient lights into a scene like this, with this in a shader, I made the fuse ambient specular right here, and then we just took the standard diffuse, and then we added some ambient lighting, and then the specular exponent. Ambient lighting is just to give it overall lighting around the shape, so there's no real dark spots, and then specular is to give where the light's pointed, it gives like a shiny point on it, it gives a kind of look to it. Add it all together. You can do it through all this. I put it in one shader file so it's easier to implement, and then that's the shader file right there. You just have to load the shader right here with the shader file point. Make the materials for it. So attach the shader to the default, and attach the shader to the shader file element there, and link it. And then the rest for that was just over here, where to use it we just set the material for the game logic to the shader, and then that will then draw the lighting for it. So if we run it, you'll see there, and then if you press lighting, you can see the balls get a little bit brighter. There's some ambient light around it, and this could be used to light up the fish a bit more. The fish moving around like that, and that. So a way to also do color correction for this is you could see some of the colors right there. The sky in the background is kind of dark, kind of giving this night feel, and then the blue waters. So then with color correction, we could change that to even like a day or nighttime. And the way we did it here is that in this one case area right over here, I have the material set for the lighting that I wanted with the ambient, diffuse, and specular all combined. And then all I did was just enabled the frame buffers. I just changed the colors from RGB spectrum to an sRGB, which gives us this lighter color and lighter thing. So if you look over here in the code, you can see how it's darker, all the thing over there. Add the lighting, and then press the color. You can see how it gives this purple look. Some of the colors change on the fish, so you could give off a different, you could put it as a night sky kind of feel with that color too.